For designing the waveguide port, we have to keep the tab at this simulation. Now for the first time, we are keeping the tab at simulation. So as I told you that we need to find out what will be the dimension of the waveguide port. The waveguide port can be created from here, this option which you can see here. But first of all, let us find out the dimension of the waveguide port. Go to this home. The last option which you will find here is macros. Select on it. Next you will have to go to solver. Select on it. You have to go to ports. Select on it. Next, port extension coefficient. Calculate the port extension coefficient. So very quickly what we did, we kept the tab at home, selected macros, after that selected solvers, then selected ports, after that we selected the calculate port extension coefficient. Once you select that, this dialog box will come. Now see, this is exactly the schematic of the structure which we have generated. At the lower end we have the ground plane. This yellow portion is the metal ground plane. This green portion is the substrate, the dielectric substrate that we have designed, FR4. And this is the width, the feed line. So for calculating the extension coefficient, this red border defines the waveguide port. So we need to find out what is the width, what should be the width of the port and what should be the height of the port. So for finding, we have to give three data. One is this W. What is this W? W is the width of the feed line. We have chosen it to be 3. So put 3 here. This H is basically the height of the substrate. The substrate extended from 0 to 1.6. So the height is 1.6 only. So put 1.6 here. And this is ER. ER is basically the relative permittivity of the dielectric substrate FR4, which we have chosen to be 4.3. So put 4.3 here. 4.3 here. After that, press on calculate. See, a constant K is coming. The value of K is 6.7. And it is also mentioned that the value of K should lie in between 3.6 to 6.7. That means the value of K that you are getting is the maximum value it is showing. Now look in this picture. At no cases, at no situations do we need the value of K. Instead what we need is the value of K multiplied by H. So if you multiply K 6.7 and 1.6, the value of H, you will get the product as 10.72. So let us make it a round figure. Let it be 10.5, for example, 10.5. So K star H is 10.5. So from the edge of the feed line, it is extending 10.5 millimeter. But our coordinate axis is not placed here. It is at the center. So from the center, it is how much away? 1.5 is this edge. And from this edge it is 10.5. So from the center, from the origin, the dimension, the x dimension of the waveguide port should be minus 10.5 minus 1.5. That means minus 12 to plus 12. That is the x direction. That is the x dimension. Minus 12 to 12. Again you note one thing. This waveguide port is not extending up to the bottom of the ground plane. It is extending up to the bottom of the substrate. So it should start from 0 and go up to some height. But this minus 12 to plus 12 or whatever this height is, that is basically the maximum terminal value of the dimension of the waveguide port. We will not use the terminal value also. We will keep the dimension of the port to be a bit less of minus 12 to 12. So let us say that we keep the dimension to be minus 10 to 10 and say 0 to 9, whatever. Okay, this is just for an example I am telling you. So you close this window, go to simulation, select waveguide port, See, port number 1 is there. That means the first port you are defining. Okay. Now what should be the direction of the port? See, X direction is selected and X direction is this sideways. Okay, see this bordering, this is sideways. But we will not feed the structure from the sides. We will not do that. If we select Z direction, then it is either from the bottom or from the top. We are not feeding the structure either in this way also. So if we select Y, see either from the top or from the bottom. Now it is matching our requirement because we will be feeding the structure from this bottom end only. So we will select Y. No need to change this positive or negative because positive is this one, negative is the upper end. We are not feeding from the upper end, we are feeding from the lower end only. So keep it as positive. See, here full plane is chosen. That means the entire this edge will be the waveguide port, which is not what we desire. So we need to change this. We need to customize. We need to give the values for Xmin, Xmax, Zmin, Zmax. So for that we need to select this free. From full plane, generally full plane will be chosen, will be activated by default. We have to choose this free. So what was the dimension for Xmin? Xmin was minus 10 to 10. So select this, remove this entirely and put minus 10. Tab 10. So Xmin is minus 10 to 10. See, as you are giving this data, this is also changing its dimensions. Now Zmin, see, I have selected Zmin, this minus 10 to 10 is shown here. Zmin is what? Zmin was 0 because it did not include the bottom of the ground plane. It extended from the bottom of the substrate only. So Zmin is 0. Zmax we consider to be 9. Okay, let it be 9. See what happens? The waveguide port is getting its dimension, but still now it is not getting attached with this length, with this edge of the substrate. Why? Because the Y position we have not customized, we have not adjusted. That Y position should be minus 30. If we want this waveguide port to be attached here, then the waveguide port should have the Y orientation, the Y coordinate to be minus 30, which is the same as this lower end of the substrate. So for getting that adjustment done, we have to make this free normal position activated. That means the Y position also we are getting to be free. Once you do that, you can actually change this Y position. See, I can change it. Okay. So put it minus 30. Okay. Nothing else you need to do here. Preview. See, it has come up. Apply and OK. Done. Now, in this case, I want to alert you people that in some systems, depending upon the data which you are providing, depending upon that dimensions, depending upon the working conditions, there can be an error occurring in this case. I mean, it is completely a system generated error. You need not worry about that. I will tell you what to do in case of that error comes. See, in the navigation tree, you have these ports. Under these ports, you will get a list of all the ports that you have designed. If I double click, see, 2 ports are given, port 1 and port 2. But how many ports have we actually designed? We have actually designed 1 port, that was port number 1. But a replica of that port is created by some reason. So if this happens, I mean, in some of your systems this may take place. If this happens, we need to delete the replica. That means we need to delete port 2. How will we do that? Select this port 2, right click on it and delete. Do you really want to delete? Yes, I want to delete. Done. Now see, only 1 port is there. Okay. So this is the structure. Now after this structure, we are actually at a situation where we can simulate the structure. So for simulation, what we have to do, see in the navigation tree, there is this field monitors. We will right click on this field monitor. When this new field monitor will come, click on this new field monitor. This dialog box will come. Select far field RCS, where RCS stands for radar cross section, RCS. But why we are selecting far field? Because all the antenna measurements, all practical measurements of an antenna are performed not in the near field, but they are done in the far field. So far field is present only in this third option. So we are selecting this far field radar cross section. Now what type of antenna we are, our motive is to design a broadband antenna, a wideband antenna. So we will select this transient broadband. See, automatically some number of samples, that means how many samples the platform will generate, how many values the platform will generate. If you increase the number of samples, that will actually give you a better curve, a smooth curve. But at the same time, the computational time will be more. On the other hand, if you reduce the number of samples, you will get a step-like curve. You will not get a gradual curve, smooth curve. You will get a step-like plot. So that is not that much accurate. But at the same time, the computation should be very fast. So we will optimize. We will increase this a bit. Let us keep it to 30. You have to do nothing else. This far field RCS, transient broadband, and keep it to 30. You can keep 40, 50 also. That will give you more accurate results. But at the same time, the computational time will be more. Apply. OK. Then you go to home and start simulation. See, once you get these tabs are running, that means the simulation is actually performed. So you have to wait for some time till the simulation is completed. After that, you will be able to get the results. See, as the simulation is being performed, what stage the simulation is at, that means what the system is performing now, that you will be shown. Whether it is computing coefficients or whether it is computing the far field powers, what it is doing, whether it is saving the results, whether it is doing some 3D analysis, whatever is done, it will show you. So now we are at a stage where we have to wait for a while for this simulation to be done, and following that we will get the results. If we would have selected some more number of samples, for example, in place of 30, if you would have selected 50 samples, then we would have got a more accurate result, but at the same time, the computation would not be this much fast, as you can see here. So it is also showing you approximately how much is left for the simulation to be done. So these things you have to optimize. If you want a very accurate result and you don't have any particular time constraint, you can go for increasing the number of samples. Actually, in research oriented applications, when you are given time for providing the results, but at the same time it is desirable that you give as much accurate results possible as you can, then basically you can increase the number of samples. But commercially, on an industrial perspective, where you need to give the data, where you need to give the results very fast, maintaining a certain deadline, timeline. There you have to optimize. You have to decrease the number of samples to a, legitimate level so that it does not deteriorate the results much. And at the same time, it minimizes the time required for obtaining the results. So once this simulation is done, you will be able to get the results under the navigation tree.